Okay, fifth graders, so now we're going to move into math class. So as you guys know, every time we go into math class, whenever I say 3, 2, 1, you guys say blast off. Let's practice. 3, 2, 1. And the kids would say, blast off. And remember, whenever we do that, that means you look up front and your eyes and ears are listening and watching me, and you're ready to learn and blast off into learning. So along with that, let's move into our learning. So I would like everyone to pull out your math minute. I'm going to set a 3-minute timer, and you guys have 3 minutes to work on it by yourselves as you practice it. It's about the unit fractions, dividing by unit fractions, and dividing unit fractions by whole numbers like we did yesterday. So it's good practice from what we did yesterday. Okay, I'm going to start the 3-minute timer. Ask me if you have any questions. And students would work during that 3-minute timer. I would most likely turn off the sound on that timer so it wouldn't be distracting to them. Okay, everybody, have you guys worked through them? Awesome. So now I'm going to set a 1-minute timer, and you guys are going to talk with your peers about any ones you might have had trouble with, any of the strategies you used, anything you remember about dividing with these unit fractions. And the students would talk for 1 minute, and as they were talking, I would be walking around and checking kind of their thought process and making sure there weren't any misconceptions or confusions that I needed to clear up. Okay, class, awesome. Thank you so much for going over those with you guys, with each other. I heard a lot of really good math concept thinking. So now let's go over the answers and our strategies as a class. So let's just Okay, so for the first one, it says 5½ divided by 1/2. Can anyone explain their strategy to me? And Julie might say, so I drew 5 rectangles or 5 squares and I divided them in half. And I see that there are 10 1/2 pieces in the 5 pieces, in the 5 holes. And she might explain that 5 divided by 1/2 really means how many 1/2 size pieces are in 5. And she would then say 10 for her answer. I may call on Mark to give his example for number 2. And Mark may explain that he wanted to use a number line. So for his number line, he has 0 from 2, 7 marked on there. And between each interval, he divided it into thirds. And then he counted how many thirds there are from 0 to 7. And he sees that there are 21 thirds in 7. Because 7 divided by 1/3 basically means how many 1/3 size pieces are there in 7. And you can see from the number line that there are 21 pieces. Now this is a more advanced model, and most students would typically use the visual fraction model, but some higher level students may understand how to use this number line to display their thinking. And I would continue to do that with 3 as well. Since 4 is a little bit different, I may ask John to explain his answer. And he would explain that first he drew a rectangle that is divided into 1/5, and he colored in the 1/5 to show 1/5. And that's shown with that red right there. And then he would say that he divided that 1/5 into thirds, as you can see. And when he divided that fifth into thirds, you can see that 1/5 divided by 3 is 1/15 because there's 1/15 piece left. The 1/15 piece is colored in and is what is when 1/5 is divided by 3. And I would continue and have students explain their thought processes for 5 and 6. Once students have done that, I would make sure that students in the audience weren't having any misconceptions or confusions, and I would have students be able to ask the students that are presenting their strategies questions if they were confused about something. That way students really understand this baseline of information before we move on to applying it to word problems. So then, next, students, we are going to go over our I can statements for the day. So first, I'm going to say the I can statement, and then you guys are going to repeat it. So I can divide whole numbers by unit fractions in a word problem. Good job, guys. I can divide unit fractions by whole numbers in a word problem. Ooh, good, super job right there. And lastly, I can explain my division process. Great job, guys. So now we're going to remember these I can statements as we go through our lesson, because this is what's going to keep us motivated to continue on. Okay, now I have some questions for you. So, Emma is throwing a Halloween party. How many of you guys had some Halloween parties? Thumbs up if you guys had any fun Halloween festivities you just did. And kids would put up fun wings up or fun thumbs up if they had some fun stuff. Yeah, so it was just Halloween. So this fits really well with what's going on right now. So Emma has 6 s'mores pies to feed all her guests. Wow, that's a lot of pies. If each pie can feed 1/5 people, how many people can Emma invite to her party? Use words, pictures, and equations to explain your answer. Okay, so we have a problem here, don't we? Yeah, Emma wants to know how many people she can invite. So first, let's think out what we need to figure out for this problem. Okay, so Emma is trying to figure out how many people she can invite to her Halloween party. Or she's trying to figure out how many total 1/5 size pieces of pie there are in 6 pies, because each person can have 1/5 size piece of pie to eat. So that's what we're trying to figure out here. What numbers do we have to work with in this problem? I see that we have 6 s'mores pies, and then we have 1/5 size people, or 1/5 sized pieces that we are going to be working with here. What operation would we use, and why would that work the best? Well, I think that division would work the best, because we're trying to figure out how many 1/5 size pieces are in 6 pies. So we are dividing each of the 6 pies into 1/5 pieces to determine how many total slices there are in those pies. So what roles do these numbers play into the problem? So 6 is going to be the divisor, and 1/5 is going to be the dividend. So we are going to be finding 6 divided by 1/5. Awesome, guys. What types of models could we use to solve this problem? I think a visual fraction model would really work, or maybe even a number line, depending on what you see here. And how would we write this problem? I already explained that one, but we'll go over it again. 6 divided by 1/5. Okay, class. And I would be writing these answers on the board, but I just said them out for this presentation. So now class, I want all of you guys to work within your pods and with your partner to work out these problems. You can use that model, you can use all the information in the problem and those fraction models that you can do. Okay, we'll come back together after you guys have some answers. And then as students work through the problem together, I would be circulating the classroom asking to clear up any potential misconceptions or confusions that they might be having, and kind of listening to student ideas and thoughts to make sure they're really understanding it. I might go up to different students and ask them, like, what model did you use and why? And let's say Julie says, I used the visual fraction model just because there's 6 pies and you're dividing them into 1/5 size pieces. And I thought I could just divide these 6 circles into 1/5 size pieces. Or I might ask Matthew, how do the number of rolls show up in your model? And he might be using one of those visual fraction models, and he might be like, well, the 6 is those circles that are in my picture, and the 6 is the divisor, and the 1/5 size pieces are what are being divided out into the visual fraction model. And then I might ask Samantha, what is your answer? And does this answer make sense? And Samantha might say, I got 30. And I think 30 makes sense because she wouldn't be inviting less than 6 people to a party, because then the slices of pie are smaller than 6. So it makes sense that it would be bigger than 6. And I think 30 makes sense overall because there's 5 slices in each pie, and there's 6 pies, so 5 times 6 would be 30. So yeah, 30 would make sense here. And as I'm doing this, I would just see some students that are working really well, and I would ask if they would share their strategy later, and as we do our classroom discussion. Okay, class, you guys did so good with that. So now I'm going to have a few of you guys share your strategies so we can see what is going on and make sure we all understand what's going on. So, Julie, can you please explain what your visual fraction model here is? Sure. So I have 6 pies, and they are all divided into 1/5 sized pieces. And I know that this question is asking me how many 1/5 size pieces are in 6. So then I just have to count. And I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There are 30 pieces in the pie. So that means Emma can invite 30 people to her party. Perfect job, Julie. And then Luke might say, well, I used a number line, and I knew that there's the intervals 0 to 6. So then in between each whole number, I divided it into 1/5 because you're asking how many 1/5 are in 6. And when you do that, you see that there are a total of 31/5 in 6. Wow, good job, Luke. That makes a lot of sense. So see, you guys, we can see here that we are looking to see how many 1/5 sizes, 1/5 pieces are in 6. And I see something. Do you guys see something? Yeah, I see that there's more 1/5 size pieces in 6, and it's greater than 6. So I wonder if when you divide a whole number by a unit fraction, if the answer is usually bigger. Well, from this and from our math minute, I think we can say yes. So I think whenever you're dividing a whole number by a unit fraction, they're usually bigger. So good job, guys. So now we're going to do another question, but this time I'm just going to read the question, and you guys are going to figure out how exactly to work it out. I'm not going to model all the different steps for you guys. So after the party, Emma and her 3 friends split the leftovers of the cake. If there was 1/4 of the sheet of cake left, how much of the sheet cake does everyone receive? Use words, pictures, and equations to explain your answer. So students, get back with your partner and figure this out. And you guys are going to use the modeling that earlier and use that thought process that I modeled on how to figure out what numbers to use that now yourselves. Okay, as students are working those out, I will be circulating the room and evaluating their thought process and making sure they're understanding what's going on. As they're also doing that, I might go around and ask students clarifying questions. So I might ask Nathan, what model did you choose and why? And Nathan might explain that he used a visual fraction model just because it made sense to him, and that you're looking at cake and then you can have 1/4 size piece of cake and then you can divide that into 4 pieces. You might ask, what are the different roles that the numbers play in the problem? And Julie might explain that 4 is the divider and 1/4 is the dividend. And stuff like that. And as I'm going around, I'd be searching and making sure students are understanding, and I'd be looking for good examples that students could share for the class in the class discussion a little bit later so that students can understand what's going on. So good job, class. I really heard some good mathematical thinking. I really liked how you guys worked together so well. Let's see what we came up with. Okay, so Emma has 1/4 of a sheet of cake left, and then she's dividing it into between her 4 friends. So we know that that means 1/4 divided by 4. Good job, guys. So now let's do the math on that. So Julie, can you explain this one for us? Sure. So first I drew 1/4 of a sheet cake. I colored that in, and then I divided that into 4 other sections. And I see that when you divide it into 4 other sections, you have a 1/16 piece of cake left. So I see that each of Emma's friends would get 1/16 of a piece. And I think that this answer makes sense because if you're dividing a piece of cake into 4 other pieces, then it makes sense that the piece is going to get smaller than 1/4. Wow, good job. Good thinking, Julie. Can anyone explain it more? Or did anyone come up with any other ideas? And I would have students explain any other ideas or thoughts that they might have about this scenario, just to make sure students understand what's going on with the math. Perfect. Good job, class. So now let's go back and let's talk about some summarizing questions. So what are the 2 different division problems we dealt with today? And Samantha might say division of whole number by unit fraction and division of unit fraction by whole number. Good job, Samantha. That is just what we did today. what did you guys learn about the process of dividing a whole number by a unit fraction? And I call in some different students. So Penny might say, well, I learned that the quotient is usually larger than the dividend. And then Matthew might say the quotient, it usually essentially means how many times does the divisor go into the dividend. So that kind of means like when we were asking 5 divided by 1/3 equals, that means that the answer is how many 1/3 size pieces are in 5. Wow, good explaining, Matthew. I liked how you used the example. And then other students may just explain how they used a visual fraction model. So Stu may explain that when we use a visual fraction model, we draw these big holes and then we divide them into pieces of a unit fraction. So like when we divided on the math minute, when we had 5 divided by 1/2, we had 5 whole pieces and we divided them into 1/2 size pieces. And then we counted how many pieces were in total. Wow, good job, Stu. Thank you for explaining that so well. What did you guys learn about the process of dividing a unit fraction by a whole number? Well, I learned that, says Susie, that the quotient is usually smaller than the dividend. And we saw that really well when we did the problem just now. And this makes sense because you're dividing the unit fraction into smaller pieces. So that would make sense that it would be smaller. Wow, good job. Good explaining, Susie. And Jared might say, the quotient is how many times does the divisor go into the dividend? Wow, yeah, good job. That's usually what it means for all of them. Yeah, good job, Jared. And then Chloe might say, well, when we're using a visual fraction model for these, I see that we draw a rectangle usually, and we divide it into the size of the unit fraction, and then we divide that into what the dividend tells us to divide it into, the divisor. Yeah. We divide it into what the divisor tells us to go into dividend. Oh, good job, Chloe, for clarifying yourself and explaining and checking yourself on your vocabulary. Yeah, so that's usually what we did. Like in the example, we divided a 1/4 piece of cake into 4 of those other pieces. And we saw that in our visual fraction model. So good job, guys, explaining how we use the different visual fraction models and the different concepts going on with those. Do you guys have any questions about this process? And students would either ask questions or not, depending on if they understand or if they want to ask any questions. Perfect, guys. So now that we've gone through this, let's read these I can statements again. I'll say them and then you guys will repeat them. And we'll make sure in our head that we've gone through them. So I can divide whole numbers by unit fractions in a word problem. You guys think we did that? Good job. Yeah, I think we did that pretty well. I can divide unit fractions by whole numbers in a word problem. You guys think we did that? Yeah, I think we covered that. Good job. I can explain my division process. Yes, I think we covered that too. Good job, kids. So now, if you guys will pull out your exit tickets, I have a 1, 2, and 3. I want you guys to write a summary of the I can statement and all that you learned about that I can statement on your exit ticket. And as students are working, right before you guys start working on that though, I just want to tell you guys that tomorrow we will be having a quiz about division with unit fractions. And it's going to be with the math problems like we've been working on these past 2 days. So we're going to have math problems like not without the word problems, and we're going to have word problems too. So we're going to have a mixture of both. So please ask any questions if you guys don't understand this concept, because we'll be doing our quiz tomorrow. And then students would work on their exit ticket, and then they would turn that in, and then we would move on to the next lesson, or we would move on to whatever is next in that day. Thank you.